Thank you for tuning in once again for another tutorial. If it's your first time joining, please hit the subscribe button below there and like the video. Okay, so for today's video we're looking at surds. So surds are basically just square roots of numbers that cannot be simplified into a whole or rational number. Examples of surds, we have talk of square root of 3, square root of 7, such numbers, square root of 15. All these are examples of surds. They cannot be evaluated directly. They are irrational numbers. So these are our focus. Yes, so in dealing with surds, we have some rules that we work with for us to be able to solve any question given on surds. So let's start with maybe the first rule. So for the first rule, if we have a situation of A multiplying with B, this can be split into square root of A multiplying square root of B, and vice versa. You can either start from this point, go in this side, or you take it from that point, going to the other end, and it's all okay. So let's take, for instance, we have square root of 5 times 6. So this can be split into square root of 5 multiplying square root of 6, and that's okay. The second rule, if we have, let's say we have A over B and this is O under a square root. So the square root can split. We will have a situation of square root of A over square root of B. So in the same vein, if we have 8 over 7, then we have 1 square root. We can split the square root by having square root of 8 over square root of 7. Then the third rule we can look at is we can look at such a rule of having B over the square root of A. So here we can rationalize the denominator by multiplying the numerator and denominator by the denominator. So there will be questions where they say rationalize the denominator. So you can rationalize this by multiplying both the numerator and denominator by this same denominator. So that will be, we'll multiply this by the square root of A over the square root of A in order to simplify it. And this becomes B square root of A over just A. And by doing this, then you've rationalized the denominator. We can have an example. Let's say we have 5 over the square root of 3. So here we'll have 5 over square root of 3 multiplying square root of 3 over square root of 3. So we multiply with a denominator, and this becomes 5 square root of 3 over just 3, and it's simplified like that. The fourth rule that we can look at is a case where we have this situation. So this could be scalar multiplication, addition, subtraction. So in this case, if these are having the same kind of radical, we can add the coefficients or subtract the coefficients. Or in better terms, we can factor out the radical which is common, so that we end up having A plus or minus B, then the square root of C. So in short, we can just add or subtract the coefficients that we have. Take for instance, if we have 5 square root of 6 plus 4 square root of 6. So here we can add the coefficients because the radicals are the same. Or we can factor out so that we have 5 plus 4, then square root of 6, which is 9, square root of 6, and it's done there. The fifth rule is that if we have C over, let's say, A plus B, the square root of n. So to solve this, you need to multiply both the top and the bottom with the conjugate of the bottom. So that means if we're to solve this, you're given such an expression, we write it A plus B square root of n, then we multiply it by A minus B square root of n over A minus B square root of n. So this is the conjugate of the denominator. So if there was a minus sign here, we would have had a plus sign here, and vice versa like that. Then from here you can simplify, you multiply both the numerator and denominator to get your solution. Let's look at an example. Let's say we have 3 over 2 minus square root of 2. So this is, we write the expression times, so we'll multiply with the conjugate of this. So since there is a minus here, we'll multiply with what has a plus. So 2 plus square root of 2, 2 plus square root of 2. Then we simplify it. So 3 by 2 is 6 plus 3 by square root of 2, it will just be 3 square root of 2 over. Then multiplying these two, so if you notice, this is more of a difference of 2 squares. Just to jot your memory, if we have A minus B multiplying A plus B, this is just equal to A squared minus B squared. Instead of you starting to multiply A by negative B, so it's just you square both sides and you subtract them. So these are difference of 2 squares. So we can just apply the same concept. Okay, so that means we just square, so it will be 2 squared minus square root of 2 square. So this will give us 6 plus 3 square root of 2 over the square of 2 is 4 minus the square root. If you square it, it will just be 2. This will give us 6 plus 3 square root of 2 over 2, and it's done. So basically this is all you need to know on the rules of solving any kind of question on Surds. We can look at more questions. Let's try something maybe a bit, but anyway, there's nothing complex with what we've looked at. Okay, let's look at this question. So to solve this, we need to multiply the denominator and the numerator with what is on the denominator, but the conjugate of the denominator. So that will be, we write the expression so we multiply with what is on the denominator, but we just change the sign. So that will be 3 square root of 2 minus square root of 3 over 3 square root of 2 minus square root of 3. Then we simplify it. So multiplying the numerator, we have 2 square root of 3 multiplying 3 square root of 2. So we can multiply the coefficients first. So 3 and 2, that is 6. Then square root of 3 by square root of 2. Sorry. Remember the first rule. So if we're multiplying square root of 3 by square root of 2. So remember the first rule. If we have square root of 3 by square root of 2, what we have is 3 by 2 under 1 square root, which is just square root of 6. So we just have the square root of 6 here. Then square root of 2 by the coefficient 1 here to be minus 2. Then square root of 3 by square root of 3 will just be 3 over. Then we'll go to the square root of 2. Square root of 2 by square root of 2. First there is a 3 in front, so we'll just have plus 3. Then square root of 2 by square root of 2 is just 2. Then the 1 coefficient by the 1 coefficient will just have minus 1. Then square root of 2 by square root of 3 will just have square root of 6. Then on the denominator, we'll square both sides. It's a difference of 2 squares. So we'll square both sides, then we subtract. So that means we'll have 3. Okay, let's just put them under 1 square root. So 3 square root of 2, then we square it, minus square root of 3 square. So on the numerator, these two are the same. This is 6 and this is 6. They will subtract. So we'll end up having 6 square root of 6 minus square root of 6 over. When we square here, we'll have 9 multiplying with 2 minus 3. Remember the rule that we had looked at? Is it rule 4? So we can, since they are having the same radical square root of 6, we can add or subtract the coefficient. So since there is a 1 here, there is a 1, so it will just be 6 minus 1, that's 5. So we're having 5 square root of 6 over. This will be 18 minus 3, which is 15. We can simplify by dividing 5. So we'll have square root of 6 over 3. And that's our final solution. Example. So for this example, we have been given to simplify this kind of expression. So since it has this kind of a denominator where there is a minus, we can multiply it with a conjugate to get the solution. So that is, we'll multiply with 1 plus square root of 3 over 1 plus square root of 3. So even before we go further, I think we can simplify these expressions. They can be simplified. You agree with me that if we take square root of 27, this is applying the first rule. This is 3 times 9 under 1 square root. Then when we split the square root, we'll have square root of 3 and square root of 9, which is just 3 square root of 3, because the square root of 9 is 3 and we maintain the square root of 3. So we can at least write square root of 27 as this. The same can be done for square root of 75. Square root of 75 is a multiplication of 3 and 25, and we know the square root of 25 is 5. So here we'll have 5 square root of 3. Then the square root of 108 is a multiplication of 3 by 36, of which we know the square root of 36 is 6. So that is, we'll have a 6 square root of 3. So variables, we replace these variables with where we have square root of 27, 75 and 108 to make our work easier. Let's do that. So with square root of 27, we're replacing with 3 square root of 3 plus 75 is 5 square root of 3, and then with the negative 108, we're having negative 6 square root of 3 over 1 minus square root of 3. 1 to multiply with the conjugate, which is 1 plus square root of 3 over 1 plus square root of 3. Then this can be simplified. This numerator can be simplified. Since they are having the same radical, we can work out the coefficients. So that is 3 plus 5 is 8. 8 minus 6 is 2. So we're having 2 square root of 3 over 1 minus square root of 3, and we get to multiply this with a conjugate. So now multiplying this, we'll have 2 square root of 3 by 1 to just be 2 square root of 3, plus 2 by the coefficient 1 is just 2, then square root of 3 by square root of 3 will give us 3 over, so these are a conjugate of each other, so we'll just square 1 squared minus square root of 3, also square it. That is, on the top part we'll have 2 square root of 3 plus 6 over 1 minus 3. This gives us, we can rewrite the numerator will be 6 plus 2 square root of 3 over negative 2. Dividing through with negative 2, we'll have negative 3 minus square root of 3, and that is our final solution. Okay, let's look at another example. So this says express square root of 2 plus 1 over square root minus 1 in the form a square root of 2 plus b, where a and b are integers, and hence state the values of a and should be state the values of a and b. Okay, so the obvious thing we can do here is to rationalize the denominator. So that is, we'll write it square root of 2 plus 1 over square root of 2 minus 1. So we'll multiply with the conjugate, so square root of 2 plus 1 over square root of 2 plus 1. So this is the conjugate for the denominator. So we'll multiply the numerator, that will give us square root of 2 by square root of 2, that's just 2, plus square root of 2 by 1, just be square root of 2, plus the 1 by the square root to be square root of 2, then 1 plus 1 times 1 is just 1. Then over, the denominator is the difference of 2 squares, so we'll square both sides, we'll end up having 2 minus 1. So simplifying the numerator, we'll have this 2 plus this 1 giving us 3, plus square root of 2 plus square root of 2 will give us 2 square root of 2 over 2 minus 1 is just 1, so we can even ignore it. So this is our final solution. Then the expression says, so we've expressed it in the form, so we need to express it in that form, so we need to just rewrite it. That will be 2 square root of 2 plus 3. They told us to state it in the form a square root of 2 plus b. So this is the form that we've expressed it in. Then they've said state the values of a and b. So we can say therefore a here is equal to 2, and then b is equal to 3. Then we're done.